Alright, y'all, we're going to start our second benchmark review day today. This is our last day of review, so let's make sure that we make the best of it so we do well on our benchmarks. First off, we're going to have one starting every Friday. So our Science Star of the Week is Miss Michelle Howard. She has done an excellent job, comes into class every day, does her work, is all business, and has done really well in the class. So she's our example setter for this week. Congratulations to her. Our first note of the day is the atomic number is the number of protons or electrons in an atom. And the atomic mass is the number of protons and neutrons. So when I take a look here at my atom, I know that it has 2 protons, so I'd put here 2 protons. And its atomic number is also 2. It also has 2 electrons, so I know that it has 2 electrons. And my nucleus also contains 2 neutrons, so I know that if my atomic mass is 4, and my atomic number is 2, I subtract them to get those 2 neutrons. Our practice problem number 1. Look at the following atomic diagram. Which element from the periodic table is being represented? So what I want you to do is I want you to count how many protons and electrons we have and figure out which element is it. Our practice problem number 2. What I want you all to do is I want you to look at my atom and I want you to figure out what is the atomic number and what is the atomic mass. Remember, my atomic number is my number of protons and my atomic mass is my number of protons and neutrons in my nucleus. So what is the atomic number? What is the atomic mass? Our second note. We find the number of neutrons by subtracting the atomic mass and the number. And we have to round up if the atomic mass decimal is greater than 0.5. So let me explain this a little bit. I know that boron, my atomic number is 5, so I know that it has 5 protons and 5 electrons, but let's take a look at its atomic mass. I know the atomic mass is going to be 10.811, but we're going to round up. I see that 8.11 is greater than 0.5, so I'm just going to round up to 11. So I know that its atomic mass is 11. Now to find the number of neutrons, I have to take the atomic mass minus the atomic number, which means that I would have to do 11, which is the mass, minus the atomic number, which is 5, which is going to give me 6 neutrons. Our practice problem number 3. How many neutrons does oxygen have? Is it A, 8, B, 9, or C, 10? And I want you to show how you got your answer. Remember, look at the atomic mass first. Note number 3. Elements are one type of atom, and compounds are more than one type of atom. So I know that an example of my element is oxygen. Even though there are 2 atoms here, they're both the same element. So this is considered an element because they're both oxygen atoms. They are the same type of atom. However, my compound is water because I know that I have 2 different types of atoms. I have hydrogen atoms and I have an oxygen atom. So that's what makes it a compound, is the 2 types of atom. ketones. Our practice problem 4. Which of the following is a compound? Is it A, O2 oxygen, B, carbon dioxide, a carbon and an oxygen, C, carbon, or D, fluorine? Note number 4. In a temperature versus time graph, the upward slope represents increasing heat, and a flat line represents a phase change. So when I take a look at this graph, I know that as I'm adding heat, I start out with a solid, like ice. And as time goes on, I know that my slope means that I am increasing heat. My ice is heating up. But when I reach here, my ice starts to melt. However, my temperature stays the same as my ice is melting until it's completely melted into a liquid. If I keep adding heat, then my liquid is going to get hotter. If I keep adding heat to water, it's going to get hotter until I reach its vaporization point or its boiling point, in which case it's going to start to boil or turn into a gas. And when it's turning into a gas, the temperature stays the same because all of that energy is going into breaking our bonds. And finally, when all of my water is steam, it's a gas, I know that if I keep adding heat, the gas is going to get hotter and hotter. Practice problem number 5. What is happening between points E and F on this graph? Is it A, a solid is changing into a liquid, B, a liquid is changing into a gas, C, a liquid is heating up, or D, a gas is heating up? And explain why. Again, what is happening between points E and F on this graph? Note number 5. More dense things sink to the bottom, and less dense things float to the top. So I'm going to start out with my most dense thing on the bottom. Most dense things sink on the bottom, so I know that honey is my most dense. I know that corn syrup is going to be less dense than honey, but it's still pretty dense. So corn syrup is less dense than honey. I know that dish soap is going to be less dense than corn syrup, so dish soap is going to be less dense because it's floating on top. I know that then water is going to be even less dense. And then our least dense, what's floating on all the way on top, is going to be our vegetable oil. And our final practice problem. What conclusion can be drawn from the following image? So it's our same image that we have. Is it A, dish soap is less dense than vegetable oil, but more dense than water? B, honey is the most dense substance, and water is the second to least dense substance? C, water is the least dense substance, and dish soap is less dense than water? Or D, vegetable oil is the least dense substance, and corn syrup is the most dense?